My name is Milind Tambe. I'm a professor of computer science and industrial systems engineering here at the University of Southern California. I lead a team of PhD students and postdoctoral researchers affiliated with CREATE, and we work on projects focused on introducing unpredictability in law enforcement or security operations based on game theory. Terrorists and other adversaries can exploit predictability in our operations. If you're trying to protect an airport, we are always at 9 a.m. at Terminal 1, 10 a.m. at Terminal 2, and 11 a.m. at Terminal 3. An adversary can observe that and exploit that pattern. And we can't be at all terminals at all time just because of our limited security resources. So we introduce unpredictability, but this is not just rolling dice. It's more weighted randomization, it's more intelligent randomization that takes into account the fact that different targets may have different levels of importance associated with them. We built our first algorithms in the spring of 2007, and that's when we were fortunate enough to be contacted by the Los Angeles Airport Police to say whether these algorithms could actually be used at LAX to schedule their checkpoints and their canine patrols. And following Armor, we were contacted by the Federal Air Marshal Service, and again we were very fortunate that they've actually used the system that we've developed called IRIS. What IRIS does is we have limited numbers of air marshals, we have large numbers of flights. Flights have different amounts of risk, and so the question then is, how do we allocate air marshals to flights?
So we started working on this project since late 2008, and we were able to develop the system and test it in 2009, and the Federal Air Marshals have been using it since October of 2009.
Following that, there have been two more. One is called GUARDS. This has been delivered to the TSA. They are testing it. And here we are trying to use GUARDS for randomizing security operations at airports.
For GUARDS in particular, their situation is a lot different than that faced at LAX for the Armor project. And so there are a lot of new modeling techniques we're looking at. There are a lot of assumptions that are made in that base initial algorithm that we had, and so we're relaxing some of those, allowing for different kinds of security measures, allowing for different kinds of threats.
And for the next one is protect.
The problem here is how to allocate limited resources to protect ports.
We are working with the United States Coast Guard to randomize patrols.
So we're helping to generate a schedule for them that they could use to help protect all these different targets in the Port of Boston.
Our contributions are in terms of providing fast algorithms that can solve these very large-scale problems of allocating security resources to protect targets of importance to us, taking into account the fact that the adversaries are conducting surveillance and so forth.